Number 4. The suspension cables between the two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by the equation y equals 0.000098x squared minus 0.37x plus 552, where x and y are measured in feet. What is the height of the cable above the water at its lowest point? So let's take a look at our picture here. We've got our bridge. It looks like they put it on an x and y axis. So here's our y-axis, here's our x-axis, and then we've got our bridge, which is like right here, and then the cable, so this must be like a suspension bridge, swings here. And then there's our bridge, and there's our what's going on. So it says, what is the height of the cable above the water at its lowest point? So the water is going to be our x-axis, and then here is the height of the cable at its lowest point. What is this really asking us to find if it wants the height of the cable? It wants us to find the vertex. If we can find that vertex of that cable or that parabola, then we can find how high this is off the water. So vertex, I'm thinking we're going to be using x equals the opposite of b over 2a, just because our leading coefficient is not 1. So a, 0.000098, b, negative 0.37, and then c, we don't need it. So x equals the opposite of b, so positive 0.37 over 2a, which is 0.000098. Now again, for this, I'm totally using a calculator. So I'm typing 0.37 over 2 times 0.123498, which is giving me a huge number. I'm getting 1887.7551. And there are more decimals, but I'm just going to leave it at 4 for right now. Now, if I go look at my vertex, does this look like it might be out at like 1887? Which, yeah, because there's 2000, there's 1500, so that's, halfway in between. Yeah, we look like we're doing okay. But it wants to know, what is the height? Well, that's not the height, that's just how far out it is on the bridge. So that means we're going to have to find our y value. So y equals, and we're going to substitute that crazy number. So 0.000098 times 1887.7551, don't forget the squared, minus 0.37 times that crazy number, 0.7551, and then plus 552. And again, I'm just using a calculator. You can use your Desmos. Go to your Desmos and start typing it in. Just be very, very careful not to make a mistake. So 0.123498 times 1887.7551 squared minus 0.37 times 1887.7551 plus 552, and I'm getting 202.763. And then again, I know there's more, but for right now, I'm going to go with that. And it doesn't say what to round to. It just says, what is the height of the cable above the water at its lowest point? And everything is measured in feet. So let's just check. If we check our graph, does this look like it might be at about like 200 feet? And yeah, I think so, because like 250 would be right there at the middle, and then 500. So if it doesn't say, leave 4 decimals on it. That's just a good practice to get into. So height of the cable at its lowest point, about 202, 203 feet. Number 5. A group of friends is launching water balloons. The function f of t equals negative 16t squared plus 80t plus 5 represents the height in feet of the first water balloon t seconds after it is launched. The height of the second water balloon t seconds after it is launched is shown in the graph. Which water balloon went higher? So we have the first water balloon, which is modeled by this function. That's all we know. And then we have the second water balloon, which is modeled by this function, and I want to know which one went higher. Well, why don't we start with the second one, because that one looks easier to me. I want to know how high it got. So if I'm looking, I can find the vertex, and the vertex looks to me like 2.8, comma 50, 75, 100, 125, so maybe, I don't know, 130-ish. So the question is, how high did it go? Did it go 2.8 or did it go 130? And the height is about 130, where are we at up here? Feet. And that is the second water balloon, okay? Now, if you notice, this has a T, so this is your time in seconds. So at 2.8 seconds, the water balloon is 130-ish feet in the air. That is what's going on graphically. And then this would be your height. So, first water balloon, we just need to figure out, okay, well, did it go higher than that? Or did it go lower than that? And if we looked at the second water balloon and we found the vertex, well, then we're probably going to do the same thing, and we're going to have to find the vertex. So vertex, x equals opposite of b over 2a. A is negative 16, b is 80, and c we don't need. So opposite of b, negative 80 over 2 times negative 16. So that's going to be 80 over 32, and I got rid of the negatives because a negative over a negative is a positive, and then we're looking at 80 divided by 32, which is about 5/2, which is 2.5. Now, is 2.5 how high the water balloon got? And the answer to that is no. So just like down here, it was at like 2.8 seconds. It was 130 feet in the air. So this guy is at 2.5 seconds. We need to figure out how high in the air he got. So now we have to substitute it back in. Y equals negative 16 times 2.5 squared plus 80 times 2.5 plus 5. And again, grab a calculator. I'm just going to type this all in at once. Negative 16 times 2.5 squared plus 80 times 2.5 plus 5. And I'm getting 105. Which means if we were to graph this over at 2.5 seconds, this thing would be 105 feet in the air. So which water balloon went higher? I'm going to say the second water balloon went higher by about, and this is going to be an about because we guesstimated, so about 25 feet. There we go.